Have you ever looked at a complex app on your phone and just wondered, how on earth did they build this without it all falling apart? Well, it turns out there's a method to the madness. So today, let's pull back the curtain and look at the blueprints that bring order to the chaos of code.
I mean, that's the million-dollar question, right? You've got this amazing idea, but how do you actually go from that little spark to a real working product that people can use and love? It's about so much more than just writing code. It's about having a game plan.
And that game plan has a name. It's called a software process. You can think of it like a recipe for a really complicated dish, or maybe a roadmap for a long journey. It's basically a structured set of steps that keeps the entire team moving in the same direction, from day one all the way to launch.
Now, not all roadmaps look the same. In the software world, they kind of fall into two big camps. On one side, you have your plan-driven processes. This is where you try to map out every single turn of the journey before you even start the car. And on the other side, you've got agile processes, which are all about being flexible, planning a little bit at a time, and being ready to change course. This is a really fundamental divide, and it shapes everything else.
So, let's start with the granddaddy of them all, the original blueprint, the waterfall model. If you want to see a plan-driven philosophy in its purest form, this is it.
The name really tells you everything you need to know. The whole process flows downwards, just like a waterfall, one distinct phase at a time. You start with requirements, then design, then implementation, and so on. And here's the golden rule. You cannot start the next phase until the one before it is 100% complete. It's very disciplined, very structured. But, and you knew there was a but coming, here's the huge catch. What happens if the customer changes their mind halfway through? This quote just nails it. Once that waterfall starts flowing, trying to go back upstream is, well, pretty much impossible. Change is your worst enemy.
So the problems really boil down to this. Its greatest strength, that rigid structure, is also its greatest weakness. In today's world, customer needs change all the time. For most business systems, that kind of inflexibility is a total deal breaker. The world just moves way too fast for a plan set in stone. So because of those cracks in the waterfall, people started thinking, there has got to be a better way. And that led to a whole new family of models. Models that weren't designed to resist change, but to actually embrace it. And the big idea here is something called incremental development. Instead of trying to build the entire system in one massive go, you build it piece by piece. The core activities, figuring out what to build, building it, and testing it, are all woven together. You do them in these quick, small loops, adding a little more functionality each time.
And the cool thing is, the benefits are a direct answer to Waterfall's biggest flaws. Because you're working in small chunks, it's way cheaper and easier to make changes. You can get a working version in front of customers super early to get their feedback, and you actually deliver useful software to them much, much faster.
But, it's not a silver bullet. This approach has its own challenges. From a manager's point of view, it can sometimes feel a bit chaotic. If you're not getting giant design documents, how do they know if you're making progress? Plus, if you keep adding new pieces without a big upfront plan, you run the risk that the system's architecture can get kind of messy and fragile over time.
Okay, then there's another totally different approach. Why build everything from scratch? Reuse-oriented engineering is all about building with pre-made parts. It's like building a house with prefab walls instead of making your own bricks. You take existing software components or even whole off-the-shelf systems and stitch them together to make your new application.
The playbook for this looks pretty different. A huge part of the work isn't designing, it's discovering. You're basically shopping for components that might work. You often have to adjust your own requirements based on what you can find out there. Then it's all about configuring those pieces and making them talk to each other. So what's the bottom line here? Well, it's a classic trade-off. On the one hand, you can get something built and delivered super fast, with a lot less cost and risk. But, and it's a big but, you almost never find components that do exactly what you want. You have to make compromises. And you give up control. You're now depending on someone else to update and support those pieces. Okay, so we've looked at waterfall, incremental, reuse, all these different models. But here's the thing. No matter which roadmap you pick, there are 4 fundamental activities that are part of every single professional software project. They are the absolute bedrock of the whole process. First up, you have software specification. This is the what phase. What in the world are we actually trying to build here? It's all about understanding and defining the problem you're trying to solve before you write a single line of code. Next, logically, is software development. This is the how phase. This is where you take that specification and turn it into a real working system. It involves both the high-level design and the nitty-gritty work of actually implementing it, writing the code. Then comes a super critical step, software validation. This is the did we get it right phase. It's all about testing, checking, and making sure that the system you built actually does what it's supposed to do, and, just as importantly, that it meets the real needs of the customer. And finally, we have software evolution. Because let's be honest, software is never truly done. The world changes, customer needs change, markets change, so software has to constantly be updated and modified to stay useful over its lifetime. Now, let's pause on that validation step for a second, because there's a really subtle but crucial distinction in there. You'll hear two words, verification and validation. Verification asks, did you build it right? In other words, does the software match the specification document? But validation asks a much deeper question. Did you build the right thing? Does it actually solve the customer's problem? You can have a perfectly verified piece of software that is completely useless to your users. In the plan-driven world of something like the waterfall model, you can visualize this with what's called the V model. The basic idea is that for every phase on the development side, there's a matching testing phase on the other side. Testing isn't something you just tack on at the very end, it's a parallel activity that mirrors the entire construction process. All right, so we've covered different models, and we've covered the core activities that are in all of them. So what do you actually do with all this? The real art isn't just knowing these blueprints exist. It's about knowing which one to pick for the job at hand. And this right here is probably the most important takeaway of this entire discussion. In the real world, there is no single best process. Projects are messy. They almost never fit neatly into one box. The vast majority of large systems are built using a hybrid approach, a custom-made process that borrows the best ideas from all of these models to fit the unique challenges of that specific project. So I'll leave you with this question to think about. For your next big idea, your next project, which path makes the most sense? Are you going to build a waterfall, planning every single detail because you're confident in your vision? Or are you going to get on a surfboard and ride the unpredictable wave of change? The right answer? Well, it depends entirely on what you're trying to build.